Hey guys, Dr. Cadell here. Welcome to Gravimetric Analysis. So in this experiment, the idea is you're going to analyze two unknowns. We have two unknowns, one solid and one's a solution. But you're going to figure out how much stuff is in there. In the first unknown, part A, the unknown is a solid unknown. And the solid unknown is an ionic compound. And for all of them, the cation is the copper 2 ion, different anions. And our goal in the first part is to figure out what the mass percent of copper is in that unknown. So if you look at the formula for mass percent for this part, it's just the mass of the copper divided by the mass of the entire unknown times 100. So the mass of the entire unknown, that's easy to get. We're going to weigh it in the beginning, and that's the bottom number in that calculation. Now to get the top part, the mass of the copper, that's where the experiment comes in. So what we do, guys, is we take our solid unknown that we've weighed out and dissolve it in water. Now, all of these are soluble in water, so what we have at that point is a copper 2 ion floating around in solution and the anions, which we don't care about anymore. Now, copper 2 ion, when it's in solution, gives that solution this bright blue color. You'll be able to see it real easily, and that's a sign that there's copper there. What we do is we take that solution and we add some sodium hydroxide to it. Sodium hydroxide is just a source of the hydroxide ion for us. So what the hydroxide does for us, guys, is it reacts with the copper 2 ion and it forms copper 2 hydroxide. Now, copper 2 hydroxide is somewhat soluble in water, but what you'll see is it forms a slushy, a bright blue slushy, but don't drink it, right? And that's really hard to isolate, and we need to isolate it, which you'll see in a minute. So what we do, guys, is we take that copper 2 hydroxide and we heat it up. This triangle here just means heat. We add some heat, and what happens is the copper 2 hydroxide decomposes into copper 2 oxide and water. Now this copper 2 oxide, this is a brown color. It's really easy to see, and it is insoluble. So it falls out of solution really easily, allowing us to separate this from the rest of the solution, which we need to do. Because watch, once we separate the copper 2 oxide from everything else, we're assuming, and it's a really good assumption, that all of the copper that started out here in your unknown ends up here in your copper 2 oxide. So once we've isolated this, we dry it and we weigh it. Knowing how much the copper 2 oxide weighs, we're able to figure out, using the molar mass, how many moles of copper 2 oxide we have, which means we can figure out how many moles of copper we have, because it's a 1-to-1 mole ratio, right? 1 mole of copper and 1 mole of copper 2 oxide. Now, knowing the moles of copper, we just use the molar mass of copper to convert that to grams of copper. Now, guys, we have the top part of that equation. We know the grams of copper. We weighed the unknown. We know the grams of the unknown. Multiply by 100. That's the mass percent. And that's the first part of the experiment. Now, in the second part of the experiment, if we go over here, in part B, your unknown is a solution, and that solution will contain some copper 2 ion and some lead 2 ion. And our goal in this part is to not only separate those two ions from each other, but to figure out the original molarity, the concentration of each of those two ions in the original solution. So let's think about what molarity is. The formula for molarity is just moles of solute over liters of solution. So once more, guys, we need two numbers. Moles of the solute, which is one is copper, the other is lead, and liters of solution. Let's get the easy one out of the way. We're going to use a volumetric pipette and measure out 10.00 mils of that. That's going to be the liters of solution. So the whole rest of this part is figuring out how many moles of copper are in that 10 mils and how many moles of lead 2 are in that 10 mils. So here's how we do it. Take this solution, and by the way, because there's copper 2 ion in this solution, this solution will be bright blue. And that's actually useful to know, because anytime you see that blue color, you know that that's where the copper is. So the first thing we do, we take 10 milliliters of that, we measure it with a volumetric pipette, and we add some sodium sulfate. Now, we don't care about the sodium, those are just spectator ions. What happens, guys, is the sulfate ion will combine with the lead 2 ion to form insoluble lead 2 sulfate. Now it's important that the copper 2 ion does not react with the sulfate. and that will not form a precipitate. So we're selectively precipitating the lead 2 ion out with the sulfate to make lead 2 sulfate. And so what you'll see at that point is this white powder starting to form in the beaker. And so now what we want to do is we want to separate that from the rest of the solution. So I'll show you over there in a few minutes, but what we do is we filter it, which, by the way, we do in Part A also. And we collect that lead 2 sulfate. It's going to be a white powder. And we're going to check and make sure we actually got all of the lead out of this, that 10 mils. But once we do, after we filter it, we'll have the lead 2 sulfate on this filter paper that we've pre-weighed, which means that we have separated it and we can dry it and weigh it. We'll get back to that in a minute. We're still going to have our copper ion in solution. So over here, we've pulled the lead out. We have copper. So it's still going to be blue. And what we do is we take that solution right there and we add some hydroxide, just like we did in Part A. And the same thing's going to happen. We're going to form the copper 2 hydroxide. We're going to heat it up. We'll form that brown copper 2 oxide, which we can separate from the solution by filtering it and weighing it. Okay, so at this point, what we will know is how many grams of lead 2 sulfate we had in that 10 milliliters, how many grams of copper 2 oxide came out of that 10 milliliters. So what we do is, if we know the grams, the mass of the lead 2 sulfate, we can use its molar mass to find out how many moles of lead 2 sulfate. And from looking at the formula, we can see that in 1 mole of lead 2 sulfate, there's 1 mole of lead. So at that point, we'll know how many moles of lead 2 there were in that 10 milliliters. Look, we know both things for the molarity, moles and liters. We got it. The same thing down here. Once we weigh the copper 2 oxide, we'll know how many grams we have. We can use the molar mass to calculate the moles of copper 2 oxide, which, just like in Part A, gives us moles of copper 2. And now we know the 2 parts to the molarity equation, the moles of copper. Once more, it's still 10 milliliters, so we know the liters. And that's all there is to this. So why don't we go on over here and get started on the actual experiment. All right, guys, so this is Part A of the gravimetric analysis experiment. So what we're going to do is we're going to take our solid unknown, which looks like this. And as always, we have an unknown number, so we take that off, tape that in our data table. And we want to weigh out about somewhere between 1.8 and 2 grams of this. So what we do is we take our 250 milliliter beaker, place it on the balance. And because we don't care how much that beaker weighs by itself, we tear the balance out. And because we never add anything directly on the balance, we take the beaker out, put some in, go back and forth till we get somewhere between 1.8 and 2 grams. Just a little more. There we go, just under 2 grams. That'll work. Write that number in our data table. That's the mass of the solid unknown, which we'll need. And then we're going to take some, about 10 mils of DI water. It doesn't have to be exact. Pour it in. That's just the water. You can see it's starting to turn blue, kind of greenish blue. That's the copper 2 ion. And then we're going to add some sodium hydroxide. I want to make sure it's kind of all dissolved first. All right. And now I have 10 milliliters of 6 molar sodium hydroxide. So watch what happens when I add this. It's kind of cool. See that blue there? That's that slushy. That's our copper 2 hydroxide that's forming. So now what we want to do is we want to heat this up, add the heat so that it decomposes into the copper 2 oxide and the water. Now, we have to be really careful with this because this stuff's pretty dense. And if we just stick it on a hot plate and let it go, what happens is we get these bubbles forming under there, and then when they burst, they throw stuff everywhere. I mean, it's hit the ceiling before. So to avoid that, we're going to take a magnetic stir bar, pop it in there. Put it on the hot plate. As long as it's stirring, it should not bump, pop like that. So we'll know, guys, when this reaction is finished, because remember, copper 2 oxide is this brown color. So all that blue will be gone and it'll all be this dark brown color. So the stuff on the sides I want to wash down, make sure I get it all in the solution there. This is called a rubber policeman. It's good for scraping the sides like that. I don't know if you can see, but you can already see some darker color forming. That's copper 2 oxide rather. But there's still some blue, so we know it's not all been converted. Once it's all dark brown, it's done. It goes pretty quickly. Okay, so now it's done. You can see that no more blue color. I mean, my stir bar is blue, but it's all been converted into copper 2 oxide. That's that brown color. So we set it on here. The reason we set it on the wire gauze, by the way, is that the counter's kind of cold. We don't want the hot beaker on the cold counter. Sometimes it cracks. So I also have a piece of filter paper, which I've labeled. It says copper 2 oxide, part A, and my name on it. We need to weigh this too. So I'm going to take this. Now, we want to know how much this weighs by itself. So be sure to make sure that the balance says 0 before we place it on there. Close the doors. Write that number down in the data table. That's the mass of the filter paper for part A. Take it out. Now we're going to fold this filter paper and put it in this glass funnel. Now this is what we're going to use to separate the solid copper 2 oxide from the solution. So what we do is we fold this. There's a kind of particular way we fold this. So where I wrote, I'm going to leave on the outside. Fold it in half once. And fold that in half so it's in quarters. See if my name's on the outside there. Then we open it. Now, watch out. I've seen people do this. You don't want to open it this way. We're going to place it in the funnel. If you open it this way, it's not sealed. Your stuff's just going to go right through. It won't filter anything pretty much. So we open up one side or the other like this so that it's solid inside, forms a cone. Place this in the glass funnel. That's going to pop up like that. So what we do is we take some deionized water and we just get it wet. That way it'll stick to the sides and that'll prevent any of our copper 2 oxide from being lost and going through into the beaker. So now we're going to take our copper 2 oxide and filter it. So we're going to pour it in here, making sure it doesn't overflow. And you won't be able to probably get it all in there in one shot. That's okay. It takes a little while. Let it filter. If you'll notice, in the bottom, it's clear. Copper 2 oxide's on the top. Once all the water has pretty much gone through, we can keep adding this until we've got all of our copper 2 oxide onto the filter paper. Some of the copper 2 oxide is going to be sticking to the sides, so we just use some deionized water, rinse it off, make sure we get it on there. All right, guys, so now that it's finished filtering, all we have left to do for part A is take the filter paper out of the funnel, and you can see that there's the copper 2 oxide. It's still wet. So all we do is we fold it up like this, and we're going to go place it in the oven, come back in about a week, weigh it, it'll be dry, and that'll be all we need. So now we're ready to go on and do part B. So for part B, that's your unknown solution. So you get it in a tube. First thing we're going to do, guys, is use a volumetric pipette and pipette 10 mils out into a 100 milliliter beaker. All right, so that's our volume for our molarity calculations, 10.00 milliliters or 0.01000 liters. So now, you can tell it's blue. That tells us that there's copper 2 ion in there, but there's also some lead 2 ion in there. The first thing we're going to do is add about 3 milliliters of sodium sulfate. Again, remember, the lead 2 ion will precipitate out with the sulfate, forming insoluble lead 2 sulfate, but the copper ion does not form an insoluble sulfate. So to measure out our 3 mils, I'm just going to use this transfer pipette because the exact volume is not really important. It has a 3 mil mark there. And when you add it, see that white? That is lead 2 sulfate. It's already formed, completely precipitated. So now we're going to take another piece of paper, filter paper, that I've labeled with my name, and this one says lead 2 sulfate on it. I'm going to weigh it, so make sure the balance says 0. Place it on there. This number goes also in our data table. Just like before, we're going to fold up our filter paper into halves first with the name on the outside, halves again. Open it up like before, place it in our funnel. And we're going to have a second 100 milliliter beaker, which we put underneath there. And we're going to again get the filter paper wet so that it doesn't keep popping up like that. I'm going to take this and filter the lead 2 sulfate out. Pour it through. There's going to be some lead 2 sulfate in there. We want to get that out. So just use some DI water. Our goal is to get every single atom of lead transferred, if we can. Now we wait for that to filter. You'll notice that there's a blue color in the filtrate, the stuff that's coming through. That's because there's still copper 2 ion in there. The precipitate on top, which is lead 2 sulfate, will be white. Once it finishes filtering, we're going to need to do a couple of things. We need to wash it. And we need to make sure that we got all of the lead out of the solution. So we're going to add just 2 milliliters of lead 2 sulfate to the filtrate, the bottom beaker. If we see a white precipitate forming, that means we didn't get all the lead out, so we have to add that to the top of our precipitate. Once the solution has filtered through, we're going to wash the top with a little bit of deionized water, make sure we get everything through. And we're also going to check down here. We have to make sure we got all the lead in the precipitate. So all we do is we take about 2 milliliters of our sodium sulfate. Again, about 2. We'll use the transfer pipette to measure that out. And now you can see that when I added that, I did get some white precipitate. That means there was some lead still in here. So all I do is I take my other beaker, put it under here, and add this to the top of that filtrate. And what we do is we keep going back and forth. We let this filter through, wash it, check it by adding some lead-2 sulfate to make sure that there's not any in there. Once we get no precipitate forming when we add the lead-2 sulfate to the filtrate, then we can be sure that we got all of the lead-2 sulfate out. All right, guys, now that we've finished the filtration, we've checked to make sure that none of the lead has gotten through. Notice how this is blue. That's where the copper is. All we do with this filter paper here, we've already labeled, fold it up, and we're going to place that in the oven, let it dry until next week, come back and weigh that. So now all we have left to do is pull the copper out of the remaining solution. So we're going to take about 10 milliliters of 6 molar sodium hydroxide, add it. See that blue color? That's our copper 2 hydroxide. We're going to do the same exact thing that we did in part A. We're going to heat this up, decompose the copper 2 hydroxide into copper 2 oxide and water, stirring it to make sure that it doesn't bump. So just like the first part, it's exactly the same reaction, guys. We'll know it's done when it all turns brown. All right, guys, now that all of the copper 2 hydroxide has been converted to copper 2 oxide, we can tell because it's all brown. We take it off the hot plate, set it on the wire gauze. While we're waiting for that to cool just a little bit, we don't have to let it get that cool. We're going to take our filter paper that I've already labeled, weigh it, so make sure the balance says 0. Write that number in our data table. Fold it up just like before. Fold it in half. Fold that in half. Again, with the writing on the outside. Open it up this way. Place it into our funnel. Get the filter paper wet, so that it doesn't come up off of the funnel. Just like before, we're going to filter our copper 2 oxide. Same exact process as part A, guys. Make sure we get it all in there. Once that's finished filtering, just like before, wash it off, fold it up, put it in the oven, weigh it next week, and we're done. That's all there is to it.